Case number 20. We are going to verify whether the given equation is an identity. For the left-hand side, we have the ratio of 1 plus cotangent squared beta and secant squared beta, which is equal to the left-hand side, or the right-hand side rather, which is cotangent squared beta. In order for us to solve for the identity for this case, we need to understand the possibility of coming up with the transformation of any trigonometric identity into either sine, cosine, or a combination of both. And at the same time, we need to remind ourselves of the Pythagorean identities. The Pythagorean identities is actually derived from the unit circle. Here, we could have three different forms of Pythagorean identities. We start with this identity. We have the square of sine. In this case, since we used beta, we'll have beta. The square of sine beta plus the square of cosine squared this beta is equal to 1. Again, this is derived from our unit circle, which is sine can be represented by y, so y squared, and cosine being x, so x squared. And of course, they are under addition, so they can be written in different order. As long as they have the same angle, it's equal to 1. The other form of this Pythagorean identity, before we could start with checking with the identity of the given equation, is when we are going to divide all terms here by cosine beta. Once we divide all terms here by cosine squared beta, sine squared beta times cosine squared beta, sine over cosine is tangent, you have squared beta, plus cosine squared beta divided by cosine squared beta is 1, equal to 1 over cosine squared beta, being 1 over cosine is secant squared beta. This is the other form of the Pythagorean identity when we divide all terms here by cosine squared beta. And of course, the third form of our Pythagorean identity is if we are going to divide all terms of this first Pythagorean identity by sine squared beta. So sine squared beta divided by sine squared beta is 1, plus you have cosine squared beta divided by sine squared beta is cotangent. Since we have the exponent of 2, so cotangent squared beta equal to 1 over sine squared beta is cosecant squared beta. These are the three Pythagorean identities that can be used aside from the idea of transforming 4 of the 6 trigonometric identities into either sine, cosine, or a combination of both. We are presenting this because looking at our left-hand side, specifically the numerator of our left-hand side for the given identity, we have here 1 plus cotangent squared beta. In short, we can simply rewrite that as just cosecant squared beta. The entire numerator of 1 plus cotangent squared beta is just equal to the cosecant squared beta, which would mean this is still equal to, or I mean over, secant squared beta, still equal to cotangent squared beta. Now, looking at this form from the original form, this is a little bit or less complicated as compared to we have a binomial expression on the original numerator. From this, since we have now applied the concept of Pythagorean identity, let's go back to the transformation of cosecant squared and secant squared into either sine or cosine. We will no longer manipulate the cotangent squared beta here because it's simpler, and our goal is just to come up with the same identity using the left-hand side expression. Cosecant squared beta is just 1 over sine squared beta. That's just the numerator. Over our secant squared is also 1 over cosecant squared beta. This is still equal to cotangent squared beta, but let's not write it here first because we will be manipulating this. Take note, we are dividing two rational expressions. Just like dividing two fractions, you're going to use here the keep, change, flip method, meaning we keep the numerator or our dividend as 1 over sine squared beta. Instead of division, we change the operation to multiplication, and your divisor or denominator will be flipped or reciprocated. So you have here cosine squared beta over 1. So when we multiply that, numerator to numerator, you have cosine squared beta over sine squared beta. This time, let's rewrite here the goal, which is cotangent squared beta. And even if it's too obvious now, our goal is to make sure that this expression here will be the same with the original right hand side. So cosine squared over sine squared beta is actually, again, cotangent squared beta, which is just equal to the original right hand side, cotangent squared beta. At this time, we have now verified the given identity using, again, the concept of Pythagorean identities and the equivalence of the cosecant and secant squared into either sine or cosine. And with this, we are done. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.